Hey guys, this is the start of the integral review for the test sometime next week. Not really sure when it is, but I figured to start off I give a kind of a conceptual integral kind of thing to figure out why this actually works. So let's say we have the derivative of something, which is dy over dx equals 4x cubed minus 1. Okay, so we have that, so this is just math, so we can multiply this over. So this is like 4x cubed minus 1 dx, and this is 1 dy, because it's just it's like multiplying 1 over. I mean, it doesn't make a huge difference. But so we can just take the integral of both sides like it's an operation. So this is y, because the integral of 1 with respect to y, or dy, is going to be y, equals, and the integral of this is going to be x to the fourth minus x plus c. So that's just kind of like why that works and why we're taking this with dx and all of that, and that's kind of an explanation of the notation, because we're just moving things over. So I figured I'd just do a couple examples, just kind of basic stuff, and move on to harder stuff in the next video. So let's say we have an acceleration function, and we'll say the acceleration function is, I don't know, 6x plus 4, and we'll say v of 0 equals 4, and s of 1 equals 7. Okay, so that gives me basically, if I plug in a time, oops, that should be a t. If I plug in a time, this is my acceleration. So I integrate that to find velocity function, because if you integrate acceleration, you get velocity. So v of t would equal, well, that goes to a squared, so it's going to be t squared, t squared, and 6 divided by 2 is 3, so 3t squared plus 4t plus c. Okay, so we have 3t squared plus 4t plus c equals 4, because it says v of 0 equals 4. So it's like we're plugging in the point 0, 4 into this equation. So this is 0, that's 0. So c is going to equal 4 here. So we have v of t equals 3t squared plus 4t plus 4. Okay, moving on. So just as we did to go from acceleration to velocity, we integrate to go from, velocity to position. So s of t is going to equal, that goes t to the third. 3 divided by 3 is just a 1. Obviously, you don't need to write that. Plus, and this goes t squared. 4 divided by 2 is 2, plus 4t plus c. So we've got that equals, s of 1 equals 7. So this is like 1 cubed plus 2 times 1 squared plus 4 times 1 plus c equals 7. So 1 plus 2 plus 4 is 7, and which is weird because I just came up with this in my brain. So c equals 0, which works out way too well. So t cubed plus 2t squared plus 4t. Usually the examples I make up, you're getting like 7 1/28 divided by pi over 70 or something like that. Okay, so I'm just going to separate these examples. So that's just if you're given an acceleration function, you need these two values, and once you have them, you can plug them in once you find the integral to get to the next step, and eventually you get s of t equals that right there. If that didn't make sense, you can, just drop a comment and say, Rick, this isn't really clicking with me. So, no saying but you, Ryan. So I'm going to see if there's anything else, or if we can kind of move on from there. Let me just do another one with different notation. So, f prime prime of x, or f2 prime, or whatever you want to call it, equals 6x, and I kind of want to make it ugly. So 6x plus 74. Alright. we'll say f prime of, we'll make this really bad, f prime of 2 equals 3, and f of 0 equals pi. So this is going to be really ugly, and I'm just kind of doing this to make it more interesting. So we have f prime of x, we're just integrating this, so you get x squared, 6 divided by 2 is 3, 3x squared plus 74x plus c, and I can tell this isn't going to end well. So f prime of 2 equals 3, so we got 3 times 2 squared plus 74 times 2 plus c equals 3. So 2 to the 4th is 16, 3 times 16 is 48, plus 74 times 2, which is 148, plus c equals 3, so that's 196, so c equals negative 193. Well, that's gorgeous. So let me just try and remember 3x squared plus 74x minus 193. 3x squared plus 7x minus 193. So f prime of x goes 3x squared plus 74x minus 193. Okay, so, and then, what was it? F of, over here, f of 0 equals pi. Okay. So we're going to integrate this again, and great. Okay, f of x equals x cubed, 3 divided by 3 is 1, plus 74x, that's x squared, 74 divided by 2 is 37, minus 193x, plus c, equals pi when x is 0. So as 0, 0, 0, c equals pi. So c equals pi. X cubed plus 37 x squared minus 193x plus pi is what f of x is when you're given f prime of x back here. So those are just some examples, and you know, I've just shown here that you can make them out of the blue. It doesn't really matter how you come up with these. So, you know, it's just kind of some, I guess it's fun to me anyways. Fun stuff to do. But the important thing is the notations. You can have dy over dx, you can be given the integral sign. You can have an acceleration function, velocity function, you can have f prime or f2 prime. You know, you can have any of that, and you just have to know you need to integrate in those situations. So more coming in the next video. Drop a like if you appreciated it, and thanks for watching.